knew it because I had just watched the recording, so I was like, okay, I know this one.
So I think we can get through 4 pretty quick. Just a different tests. And then we can bring Courtney up to date when we start it again.
Yeah. Okay. So, yeah, number 2 should be is it Chi or I don't know. I call it cheese.
It's pronounced chi.
Yeah. Okay.
You get to learn Greek. It's statistic. So this one's chi-squared as well?
Oh, so number 3 is, I got test of 2 proportions.
That's what I got. I was like, I thought that was different.
Yeah, no, I was still talking about number 2. So number 3, yeah, is test of 2 proportions.
And is the next one the 1 proportion?
This is the one I wasn't sure. I was thinking, what did I put? See, I was thinking 2 proportions. Why was I thinking 2 proportions? Let's read it. Okay. Survey was so it says a survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 2,048 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population. So is this 1 then?
I think it's a 1 proportion.
Okay. So
if we get this wrong, it's my bad. I just think it's 1 proportion.
I'm having such a hard time with this entire unit.
We all are.
Me. And specifically with the 1 proportion, for whatever reason, like the other ones make sense to me.
Seriously, it's like, wait, what?
Yeah.
Because I felt pretty good with everything, and then we get to this, and I'm like, I'm confused.
Yeah.
You want me to do what to who for how many Skittles?
Yeah. Okay, so we'll go with 1 proportion on that one.
If we get it wrong, it's my bad. I'll take responsibility on that one.
Well, I was going back and forth between 1 proportion and 2 because I was like, I mean, really, you're dealing with 1 population here, but are they?
But are there 2 separate proportions within that population?
Yeah, and that's why I was like, wait, because it's just the male proportion in like the entire population, and then the ones that are heavy lottery winners compared against that, and so I was like, which one is this?
Still gonna stick with 1 proportion.
Yeah.
5. This one's confusing me because if we're going with each lock, it'd be an ANOVA test because that's 3+.
Okay, so this one he explained in the exam as well, and it's paired samples. So basically, because the wording is weird because you're not really sure what's going on, but he explained it as the 25 students first do the lock that goes clockwise, and then they next do the lock that goes counter, and so they're both doing it, and they would compare their scores against each other. So
that's that makes sense.
Yeah. After he like explained what it was saying, and I was like, oh well, of course that's what it is. But I was reading it going, yeah, I'm like, are they saying that 25 students are doing this test and then different 25 students are doing this test, or it just wasn't very clear.
Yeah. Okay, paired samples. Now I see it, and it's like, okay.
Yeah.
We have to learn.
That's how it was when I was going
to find the subject.
Yeah. I was going through the practice exam, watching his thing and going, oh, okay.
Wow, this makes sense now.
Okay. Yeah. Can you just sit here and explain all of the questions to me in that way so then I could see it?
Then I'd understand what's going on in my life.
Yeah. So.
Okay, that makes sense.
Okay, so number 6 says a bank employs 2 appraisers when approving borrowers for mortgages. It is imperative that the appraisers value the same types of properties consistently. And to make sure this is the case, the bank evaluates 6 properties that both the appraisers had recently valued. Which confidence interval would most be appropriate? This one's also the paired samples.
Yeah.
I just remember this from our homework before. Like, we had this question before.
Yeah.
Okay. So number 7.
They throw stupid things in here to throw us off. I hate this. Yeah, true.
Yeah, so this one I put independent.
Oh, because the psychology majors and the accounting majors are independent of each other. Yeah.
Yeah, that's what I had put because it's 2 different sets.
Yeah.
Different group. They have nothing to do with each other.
No.
So that's why I had put independent.
That makes sense. Oh, this one's a weird one. I think it's a proportion one.
Okay, this is number 8. Yeah, this is one that I skipped. I was like, Okay.
I think it's a proportion one.
I was thinking the same thing too.
I just don't remember if it's a 1 proportion or 2 proportion.
That's what I was trying to decide, but I was kind of leaning towards 2 because you have 2 different groups. You've got the double stuff and you have the regular.
Yeah, I'll go with that. That makes sense.
That's what I was leaning towards.
Well, because you'd have the proportion of regular Oreos, and then you have the proportion of double stuff, so you'd have 2 proportions. Yeah. I follow your logic.
You basically have 2 different groups. Even though they're both Oreos, they're not, it's like redheads against blondes or something. Like, they're still in one group, but they're different groups because whatever. All right, I gotta get my charger. Apparently, my computer's dying.
Well, okay.
All right. Okay. So question 9, also one that I skipped because I keep getting one wrong.
Hold on just a sec. Courtney's in the video, but she can't hear us and talk. But her video and microphone aren't working.
Really? She can't hear us, though?
That's what I'm asking. Because if she can hear us, then I can, go over my phone and try and answer questions she has.
Yeah, so she says she can hear us.
Okay.
Courtney, maybe you can just type? Like, I see your little chat here on the side of this Hangouts.
Then we can use that to just she can message her answers, I guess.
That's what I'm thinking.
That means I have to watch what's going on there. Ah, crap.
No, it's not fun. It's great until it's not working how it's supposed to, and then...
Yay, technology.
And it's a pain. Okay.
So I guess we'll continue on. Courtney, if you're still there, just either message it. We'll try and check in all the time just to see what's going on.
Okay, cool.
And if you have any questions.
She says we'll just go over it together, and if she has questions, she can ask.
Okay.
So that works.
Ooh.
Okay, so Courtney,
Question
did you book the first 4? Were you here for those?
Okay, which one did I write here?
Oh, hey, look.
Hey, I can hear you.
You can hear me?
I can
Yes,
hear you.
I can hear you.
Oh, really? That's so funny. Yeah, because I tried to talk earlier and no, you guys didn't respond, and so I was like, oh crap, they can't hear me either. Oh, so you can hear me?
I can hear you
Yes,
now.
we can hear you now.
Oh, perfect. Okay, awesome. All right, awesome. I didn't get. Let me see. The number 3, question 3. I didn't hear what you guys said that one was.
We decided on a 2 proportion test for 2 proportions
Okay.
because Brother Doria went over it. Is that what you said, Charity?
Yeah, so this is one that he went over on the practice exam thing.
Oh, okay. So
So
why is it 2 proportions though?
the way he explained it is there's the 2 different groups. You have the groups that are younger, or they're 40 years old, or they're younger, and then the groups that are 40 years older, or older than 40, basically. So you have 2 different groups that you're reporting proportions for, and then comparing them.
That makes sense.
Okay. Yeah, that makes sense. Okay. Awesome.
Okay, so we are on number 9 now.
Did you get the rest of them, Courtney?
Yeah, I got the rest of them.
Okay.
So I keep getting this one wrong. I'm not sure why.
It's the p-value, the notion of the significance level. Is that it?
Yeah.
Yeah, the significance level.
I believe.
The probability of rejecting the null hypothesis, whether it's true or not.
Yeah.
Okay.
Finally, remember that. I was like, okay, I got this.
Yeah, I got like 3 questions on this whole thing, and that was one of them.
Okay, the p-value. That one is the probability of observing a sample statistic more extreme than one actually. Right.
Yep, that's it.
I remember it's the stupidly long definition.
Yeah, exactly.
It's like, okay, that one, got that one.
I don't know why I was thinking it was like probability of the type 1 error.
Because we always mention that one, and it's like, oh yeah, it's this one. And it's like, wait, no.
Yeah.
That one's wrong.
Yeah.
All right. Because see, that's what I always get. Those 2 questions. I think homework quiz last week. I got those wrong too, or something. I don't know. I did something last week, and I got those wrong.
Yeah, those can be confusing.
Isn't the next one the 95% twice?
Yeah. That's how I
remember one of y'all mentioning that.
Yeah. That
like 95% of all 95% confidence intervals are there.
Okay. 95% of all 95% confidence. Okay.
Yeah.
Because we're in statistics, and they like to make everything as confusing as possible.
I know, they really do. How they word it is so confusing. But
yeah.
They just want to sound more intelligent, I guess. Something like that.
Using more words makes us sound more loquacious, and it's very,
yeah.
The veracity of our statements is true, and it's like, wait, what? What did you just say to me?
What did you just say? That's funny. Okay.
And
okay. No, I just am so confused in this part. That's why I'm just okay. This next part, I ended up getting all of these wrong when I was doing stuff last week.
I feel like there's not enough information.
I know, it's confusing. So for this one, Okay, well, I could just read the thing. So you take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is P equals 0.3 or 30%. What is the mean of the distribution of sample proportions? So the mean is just 0.3 then, right?
That's what I was thinking.
Okay.
Because it's basically
Makes
saying
sense.
30 adults out of 100 adults are going to be.
Yeah.
And like I went back and was watching all of the things from that section this morning because I was like, I don't know why it doesn't click. And it was saying that the mean is equal to p hat. So, look at, I'm assuming it's the same here because we don't have any other way to get any other answer. So.
Yeah.
So sorry, I had to blow my nose for question 13.
We're really not there yet.
We didn't do
Okay.
so for what did you guys get for question 13?
I got a blank space where I blew my nose. That's the way this week has been going for me with this.
Yeah, it could be where you blew your nose. So I got 0.046 on that one.
Okay. And see, I
That
got
makes sense.
0021, which I thought was too small. So
See, that's what I originally got, but then I looked at the review itself, and that answer is not on there.
That's
And so
right.
I was like, oh, it must be wrong then because it's not one of the choices. So then
So wait,
I did.
Verity, what one did you get? What number did you get?
0.0021. I basically just inputted everything into the test statistic thing.
So that is right, but you have to do the square root of that. So everything else you did was right. You just have to do the square root.
Duh.
Stupid square roots.
I know, so dumb.
Like,
It's,
I did not
so it's the
think of
0.0461?
Yeah, 0.046.
Okay.
0.046. Okay. Like now I'm just feel stupid because that was clearly the equation.
Well, yeah, but I did the same thing as you. I did the exact same thing. I was like 0.0021, and then I looked and it wasn't there, and I was like, crap, I did it wrong. And then I looked at the equation again, and I saw the square root, and I was like, oh, duh.
Well, I got it. And I was like, that seems unusually small. Like that,
Yeah.
right? But then I was like, but that's the equation. What did I do wrong? I didn't even think about the fact that there's a square root around that portion of the
Yeah.
It's always when you miss the littlest signs.
I know.
Okay, so the next one, now that I have the right thing, where is my
Oh gosh.
normal probability? 0.046. Less than. So did you get 4817 for the next one? Rounded up to 0.482.
I got 0.138.
Okay. Oh, because it's different. It's not the 0.30. Okay. I was like, wait, what?
So yeah, so this one you do the equation, so it'll be 0.25 minus 0.3 over the square root of 0.3 times 1 minus 0.3 over 100. That gives you the z-score, and then you have to plug that in.
Yeah.
And then it's less than, so you do the left side, which equals 0.138 or 0.137 something, I think.
I think it's 0.138.
Yeah, it's 0.138 because you round up, but it's like 0.1376, and then you round up from that.
Okay. So what does that equation mean? So I remember. So it's
Okay.
0.5 minus 0.30, right?
Yeah,
Right.
0.25. So you take the proportion, or the
Yeah.
one it gives you, and then you do zero point 0.3, the mean, and then that's over the standard deviation equation.
Okay.
So you take that, and it's over the standard deviation.
It's the value minus the mean of the standard deviation. I'm looking at the summaries for
There you
lesson
go.
16.
Value minus the mean. That's what it's called, value. Okay.
So
No, I'm looking at the equation right here in my notes from everything I reviewed this morning. I got it. Okay.
fantastic.
Fantastico. Okay.
All right.
So you got that? You got the same answer?
Yeah, I got the same answer.
Okay, perfect.
This is the one that's always throwing me off. Question 15, finding the margin of error. I've just
Yeah, I
completely
literally-
forgotten how to do that.
Yeah, me too. Like I just have, I have no idea how to do it. And I tried looking for it in the book and I could not find it anywhere. So I
Yeah,
was
me
like,
neither.
I have no idea how to do this right now.
I went over this
Equations,
morning.
but
Let's see, where is it? Because I went over it this morning. Yay. So to do the margin of error, it says, oh, wait. Margin of error is basically the Z, or like the, what does he call it? The critical value, which we're looking for what?
what is critical value?
1.96.
Oh,
So
okay.
the
It's the Z star.
times, yeah, the Z star, which is the critical value, is what he said in
Oh. Oh.
This is Z
6
score for
times.
95%.
Yeah,
Okay, so 1.96 then.
1.96 times what? Like times the test statistics, I guess, is that times 1 minus p hat over n square root. Does that make sense?
So it's
So
1
it's
minus
the
p
standard
hat over the square root of n
Oh, so no. So
times 1.96.
square root of p hat times 1 minus p hat all n. So the square root of is the. It's a thing that we just did that I missed this.
So it's like the standard deviation.
Yeah, that
Times-
it is. Thank you. That's what it
So
is.
it's the standard deviation times 1.96.
Yeah,
Okay.
that makes sense.
There we go.
What is that?
There we go.
Like
Okay.
it's this
Okay.
one. I'm going to write that right there because I don't know. I'm so lost. Okay. But I have
figured it out. Woo.
No, we got this, guys. We got this.
Okay. Now I'm going to try and do math on drugs. This is going to be amusing.
Divided by 100.
me.
Oh. 5, 8, 2, 5, 7, 5, 1. Okay, so I got 0.09.
Okay, sorry, I'm still trying to read through the question because, yeah. Okay, in the clinical trials, 2142.
Okay, so your P1 was 61 over 1563, right?
What?
So P1, finding proportions. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril. So P1 would be 61 over 1563, correct?
Yeah.
Oh, good.
Yeah.
Even in drug adult stage.
Going through this, going, wait, what? And so I have to see it in math form and not in word form. So I was starting to write down everything and try to figure out what I'm doing.
Yeah.
Okay, so the margin of error. All right. So shoot, this is where proportion of 2, which is not the equation that I gave you. It's a different one.
Okay, so what part are you on right now, guys? Sorry,
Still on 15.
You're on 15. Okay. Okay. So you're on 15.
Yeah.
So did we have the wrong equation?
I think there's a different one for
Oh, for the P's?
because it's
Oh, okay. I know what it is.
one for the. I give you guys the one for the 1 proportion, but this is 2 proportion.
Okay, I think I see it. My notes, if it's right. So it's Z times, or Z star, times the square root of P hat 1 times 1 minus P hat 1 over N1 plus P hat 2 times 1 minus P hat 2 over N2.
Yeah, it's that one.
Okay.
Because I went over that video this morning as well.
Okay, so this is for 1 proportion. I need to write this down. Proportion, 2 proportion. Okay, so we have to do that. Okay, that makes more sense. Okay.
And is it over N? Because I can't remember.
Yeah, over N. Yeah, so the biggest number.
Okay.
So like 1563 for the first and then 579 for the second.
Okay. That makes sense. And
Okay, so P1 is the 61 over 1563. Whatever that is, that's P1, right?
yeah.
Yes.
Okay. Well, this is the annoying one because you have to like plug it in.
Yeah, it's
Low.
this is the one that it's so easy to accidentally put the wrong number in somewhere.
Yep.
Yeah.
Okay. 15 over 579.
So for P1, you guys could get 0.03902751112.
Yeah, who for what for how many Skittles?
The P1, before I even start this equation, let me just make sure. It's 61 divided by 1563, which is 0.0390 blah, 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 blah.
Yes. Blah, 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 blah. I don't know. I haven't divided it yet.
Oh.
I'm just plugging it into the equation as a fraction, which might be kind of dangerous, but okay.
And then the N here is the 1563 and not the 2142.
Oh, excuse me.
Yeah, 1563, because it's N1 and then N2. So they're different.
Okay,
numbers.
that. Okay. So 0.00239 951 plus.
Isn't it 0, the top part of the Z test statistic thing, the equation? It's P1 minus P2, right? And we're assuming they're equal.
Yeah.
P1 minus P2.
Yeah.
Okay. Just want to make sure.
I think.
I'm going to go with it.
Okay, what did you guys get?
I'm still plugging numbers in.
Okay.
Yeah, I'm almost there. But because I know that I always make errors on my calculator, I'm doing it one step at a time. Okay, so I get 0.036. It says to 3 decimal points, so.
Okay, well, I need to do it again, obviously. See,
0.036.
Okay, so what number did we get?
0.036 is what I got.
I'm still. I got something else, so I'm doing it again. Let's see.
Oh, wait. I think I just figured out the Z-score, not the margin of error. Dang it.
Oh, really? Oh, no. Okay, percent minus A plus.
Okay, now this is where I have a problem with lower and upper because I can't remember what we subtracted from.
Okay, nope, I still got the same thing. So I got 0.016 two different ways when I did it. So,
0.06?
yeah. So what did you get again?
So I got 0.036.
0.036.
So what did you get for the proportion 1 plus the proportion 2 underneath the, like the two different equations added together? Maybe that's
I
where
got,
we can...
I got 0.00822069773.
Okay, see, that's different than mine.
Oh, but that's the square root of that. The square root of them added together. That's
Root. My square root was 0.018554274.
okay.
So let's see where we went wrong.
Does one of you do plus and one of you do minus?
Oh, you have to do plus and minus? Because I didn't do that.
No,
There's
it's,
confidence intervals.
so it's just plus
Wow.
in the equation. And then the confidence interval will be, what we're doing first is the margin of error, which,
So for the confidence interval, you can actually just plug it into Excel. You know that that Excel, the categorical data analysis hat?
Oh yeah.
So you can just go to two proportions and then you just plug the numbers in and it gives you the confidence interval and the p-value and the z-square.
okay.
But for the margin of error, so you don't do plus and minus for margin of error? Is that what you said?
You shouldn't. No.
You don't. Okay.
No, it's just
Okay,
add
good.
them to underneath the square root.
Okay, good.
The minus will be for the upper and the lower.
So 61 over 1563. 902. Kara and I did this lesson together, and it took us like 20 minutes to figure out the margin of error. It's like the hardest one to figure out, I think, out of all of them. Okay. 1 minus 0.039027. 119 times 0.0390. Divided by 15. 3. Yep, still got that same answer. Okay.
Are you rounding it before, or are you
No,
using the whole?
I'm using the whole thing.
One then for the P1.
7, 5. So 2, 5, 9, 6, 7, 3, 5, 7, 5.
I think I figured it wrong. So yours might be right. I figured out what I did wrong.
Oh, you did? Yeah, I keep getting the same thing every way I do it. So, what did you do?
So I had actually accidentally gotten my P2 wrong. For whatever reason, I wrote 15 over 61 instead of 15 over 579.
Oh, okay.
So I'm looking at this going, wait, okay, that makes sense.
Oh, okay, that's probably what happened then. Yeah, it's so hard because if you get one little thing wrong, it's all wrong.
Yeah.
And then when you're taking the test, you would have no idea. You just plug in the number, and then you'd be like, crap.
Yeah.
Andrew, what did you get?
Confused.
Oh.
I'm out of it and lost.
Okay, so then yes, I got 0.016.
Okay, yep. That's what I got.
I'm gonna go with that one. Miles of 2 witnesses. 0.016.
Do you have the equation written down?
I do have the equation, yes.
Okay. Good.
Right, yeah,
So
that's the
what
important part. Like, when you do the test, you know it.
Yeah.
Yeah, exactly.
Okay, so how do we get the lower and the upper bound? Because like when I did this homework quiz, I was like so confused.
So,
Excel.
do you remember the Excel thing that was talked about just recently? The 2-sample z-test for proportions.
Oh, I don't remember that. That's why I'm lost.
It's written in there very subtly, and because I just went back and looked at it, and I was like, oh, I feel dumb.
Yeah, it's in the book.
So I just grazed it, looked over it.
So I was gonna say, because I think with anything that says Excel, I just kind of skip over it because we're not using Excel, we're using SPSS.
Exactly.
Yeah, that's what I did, and then Kara told me about this Excel thing.
Yeah, it's in lesson
Way
17.
Okay.
So I went and looked at that, and I typed in the 61 and the 15 and the 1563 and the 579, and I've got an upper and lower bounds. Well, okay. So I think I do. I'm not sure.
Okay,
I've got
what
a z-score, I've got a
did you
p-value, and then I've got a confidence interval for p1 minus p2. And I
Yeah,
believe
so I have it too. So what did yours say?
For the lower one is negative 0.003 and 0.029 for the upper.
Yep, that's what I have too. So.
Okay, so what was it then? Lower is what?
Negative 0.003.
Okay.
Well, what type of are we doing? A P1 is less than P2, or is it equal? Is that what we're?
It's
What's our hypothesis
equal.
test? Oh, so it's equal.
Yeah, because we're just trying to see if it's different.
Okay.
So we're doing not equal. Okay, I just changed my p-value, and that was it.
Okay, so the 0.003, what's the upper?
0.029.
29. Do you have that pulled up though? Because you'll want to know where that is and how to do it.
I wrote down where to go look for it
It's in lesson 17.
because I don't know if you guys want to wait for me to figure that out.
Yeah, it's not hard. So if you just go to it, all you have to do is type in like 5 different things. It's like super easy.
Yeah,
It's
I
like-
saw. So I was watching the video for it this morning, and I was like, well, they're showing how to do it. How are they not showing how to do it in the other? Okay. But I see it because I actually still have it up. So.
Okay, perfect.
All right. So is it which one do I want to download?
So don't
Unit
download
3.
it. You could just click on the bottom.
That Unit 3 one?
Yeah.
The Unit 3 file? Okay.
Yes.
Because I'm looking at it, it says 1, 2, 3, and 4. 1, 2, and 4, like.
Oh,
Okay.
yeah, I don't know where you are, but.
Open the book.
Yeah, you want the Unit 3 one because it's 1 proportion, 2 proportion, and chi-squared.
Okay. All right.
No wonder I wasn't doing it right. Huh, this makes so much more sense.
Like, no wonder I couldn't figure out. I was trying to catch up on homework quizzes last week and going, I don't even know. Okay.
Okay, and on to question 18.
There we
Okay.
go.
So we want not equal to, right?
Yeah.
Okay.
So the first one.
The value of my test statistic. Oh. Ah. I've got
Okay, so the test statistic is 1.458.
Yes.
Okay, awesome. And then the p-value is 0.145.
Yes. Remember to change your hypothesis test in the Excel one, because you have a choice of greater than, less than, or not equal to. And that significantly changes things. Mainly just your p-value.
Yeah. Because I think the confidence interval stays the same, but the p-value changes, I believe. Okay, so the next one is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acupril is different than the true proportion of people who experience dizziness while not taking Acupril? So, since it's 0.145,
That's greater than our
yeah,
p-value, our
so
alpha level.
we failed to reject the null, right? So is there sufficient evidence? So no, I failed to reject the null. Is that what you guys put?
Yes. This one always confuses me.
Yes.
Like
Well,
these
I
ones,
just
it's like,
know.
is it? How do I answer this?
So I just know that sufficient is reject the null,
Yeah.
and insufficient is fail to reject the null.
Yeah.
Yeah.
Okay.
So it's no, I failed to reject the null, right?
Yeah.
Okay.
Exactly.
Right.
Oh, this is the
Okay. On to the next set. These ones are fun. Okay.
Is this a chi-squared one, right?
Yeah. Yeah. I swear I'm totally. Miley, I told you I know this.
Okay. So did y'all already plug this in and stuff?
I'm typing it in right now.
Oh, okay. I'm tired.
I feel you there.
I'm like feeling completely lost. Like this is the only thing of this section I got, and now I can't remember.
Okay, so I typed it into Excel
Mhm.
because screw using SPSS right now. I don't have the time nor the energy to deal with it.
You can just type this
So
in
what did you get on the test? Yeah, there's a chi-squared option in the Excel spreadsheet. You have 1 proportion, 2 proportion, chi-square.
Oh, I guess I don't have the right one pulled up.
Mom.
What lesson is that in?
It's lesson 17, unit 3, 1.
Unit 3. Okay, so 3.
Oh, it's on the bottom. Well, there you go. That makes it easy.
Oh, it's in the summary?
It's on the bottom. Okay.
So I typed those things in.
See, mine doesn't have that. Why doesn't it have that?
It does. It's way on the bottom, probably.
It's on the bottom.
So, like, there's little. See where it says.
The little tabs down at the bottom, 1 proportion, 2 proportion, chi-square version.
Yeah, but I don't. I have 1 proportion and 2 proportion, but I don't have chi-square.
Then push that.
Did you click unit 3?
I had the same thing because it's not open all the way. There is an arrow on the bottom to the side of it. It says 1 proportion, 2 proportion. Click to the right. Yeah. And it'll say sheet 1 and then chi squared or chi-squared. And then version. Do you see that?
Mine just says 1 proportion, 2 proportion version. Okay, so unit 3.
Because it's the file name is categorical data analysis _hat.
Yeah.
_hat. Okay, let's see. So it's under sample size calculations, that unit?
Is that lesson 17?
Yeah, it's in lesson 17.3.
Yeah. Yeah, unit 3.
And then like if you open up
mine doesn't have a Excel under unit 3.
Push lesson, like if you go into the individual preparation, push lesson 17 online textbook, open that up, then scroll down like to the contents, and it's 4.2.
Oh, 4.2.
Yeah, like in lesson 17, go down to 4.2, a little thing, and it'll say categorical data analysis.
Mine just says SPSS. Is that the right one?
Okay, hold on. Go back to 17.
Okay.
To lesson 17. Scroll down to 2.3.
Okay.
Click on the first one, the first click here, categorical data analysis.xls.
Uh-huh.
Should take you to help Excel tools.
Yep.
And then click the unit 3 file. And that's the one I used.
See, mine doesn't have that.
See, I did that again. I went to 4.2 and it's down there as well. I just there's one that says SPSS and one that says the XLS on the end. I just think I did the first one there.
Yeah, click on the first one, not the second
one. Mine only has one option, so.
Interesting.
I know, it's weird. I mean, this one says hat though, so this one might be. No, see, it doesn't even have the chi though. What the heck is that? Why doesn't it have that one? So it's okay. So mine says 1 proportion, 2 proportions version.
Okay, because I have 1 proportion, 2 proportions chi-square version.
Yeah, so do I.
That's so weird.
Did you get to the help Excel tools page?
Yeah, I was on that page, and it even says hat. It says hat by it. Okay.
Because it says unit 3 file categorical data analysis hat _hat XLSX.
Yeah, it's the same one. It's just not. Do you guys have Macs?
No, I have a.
Mine's not either, but I was just saying if there's. Okay. Well, oh well, because I did it in SPSS earlier, so we'll see if it's the same answers. Oh well, doesn't matter.
Statistic did you get?
I got 6.58.
6.579. Yeah.
Okay, sweet.
Oh, I see. So I opened up the one that says SPSS, and that one does not have what he's talking about, but the other one does. The one that's just for Excel does. What? I am in the middle of
the new game costs $3.
No.
Why?
Because. All right. So anyways, I'll go back to my quiz. Okay, so what did we get for the test statistic?
6.58.
Excel one, I got 6.579, but Courtney got 6.58.
Well, I rounded up, I think. Yeah, I rounded up.
Okay, so because that's what it would be rounded up. So.
But we need it to 3 decimal points, right? Or did they change that?
Yeah.
So we want it 6.
Always assume 3 decimal points.
Oh, okay.
We want the 0.579 then. All right. And then the p-value,
I got 0.087.
Me too.
That one I rounded off at 3.
all right.
So it's just barely bigger than the alpha.
Yeah.
Yeah. So should we reject the no?
Yes.
It's still greater, right?
No.
Yeah, so you say no, the p-value is greater.
Even though it's still like just barely, it's just
Yeah, even if it's just barely, even if it's like 0.051.
Yeah, that's still greater, so.
no, the p-value is greater than 0.5 or 0.05. So. Okay.
Okay.
Okay, so what do you conclude?
That old people are morning people more than night people. That's what I conclude.
Okay, so we have insufficient evidence to say that being a morning or evening person is not independent of age.
Yes. That's our hypothesis.
Yeah, the
Being a morning person
hypothesis is
Yeah, our hypothesis is that
is independent of age
they
and
are
are
independent
alternative.
okay. So we have we have insufficient evidence to say that it is not independent of age.
yeah.
So the last one?
Yeah, the last one.
Okay.
Okay.
How many did you say was on this?
There's 45.
Yeah, 45. It's a lot. Okay.
Based on the results of the sample, create a 95% interval. And put the lower and upper bounds. Okay.
So 200. If we're doing math longhand, I'm using the Excel sheet. So it's 50
Oh, that's how I did it.
out of 200.
What?
So reading the question. So a recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period.
Oh yeah, 50, yeah.
A random sample of 200 investment managers, top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs to outperform the Dow Jones over a 5-year period. Correct?
Yeah, so 50 and then 100. And then the null hypothesis is
50 over 200 or 100?
200.
Oh, 200, sorry. 200.
So the null. Is that
The point 2 then?
0.25?
yes?
No, just point 2. Yeah,
For the
20% of all investment managers. So it's the 20%. So it's 0.2.
okay.
And then they were greater than. So okay. So lower bound would be 0.190. Correct? If I'm reading this right.
Yeah. Yeah, that's right.
And then 0.310 for the upper
Yep.
bound.
Yes, sorry.
Suppose you had been in charge of designing the study, what sample size would be needed to construct a margin of error of 2% confidence?
Oh.
P star 0.2 for this estimate. So this is the equation, n equals
Yeah.
m squared times p star, yeah, all of that.
Yeah, n equals z star over m squared times p star.
So 196. The margin of error.
That's
So we're solving for
0.02.
m?
That's what?
Oh no,
The
starting for
margin
a.
of error is 0.02. They give you it.
Yeah.
Margin of error of 2%.
Yeah.
Oh, okay. That's why I was like, wait. $98 times 2 times 1 minus 0. $98 times 0.16. So I get 15.68, so 16.
Oh, I got something else. Maybe I did it wrong.
I could have done it wrong. What did you get?
I got 1537. Well, I got 1536.64. But that seems really big. So it's
Well, that would be bigger to get, because the bigger the sample size, the smaller the margin of error.
Yeah, you need it bigger.
But it'd be 1537 because we have to round up.
Is that what you got too then, Andrew?
Yeah, I got 1536.64.
Okay.
Yay, math.
Yay. Okay, so what did you
It'd
do?
be 1537 because we have to do a whole number.
Yeah. Because they're people.
Because you can have 2/3 of a person
Yeah,
as
exactly.
much as we try.
So it should be 1.96 divided by 0.02, right?
Yes,
Yeah.
squared.
Oh,
Yeah, you square that. Okay, that's
squared. And then
Times 0.02 times 1 minus 0.02.
1 minus 0.02. I didn't square it. That's what I did wrong.
that's what happened. Okay. Oh, you want to try to do it?
Yeah, I'll just do it. And there's what, okay.
Okay.
Yeah.
Perfect.
That's what I this stupid squared thing.
I
Okay.
know. Slow down.
The root messed me up before too. It's stupid. Looking at the equation right and not trying to do it too fast. Okay.
Okay, so then on the next one, one of the top 10 business programs performs better than other investment managers. So which of the following pairs of hypotheses is the most appropriate for addressing the question?
Better than would be greater than.
So,
right?
yeah, so it'd be greater than.
So P is greater
So
than.
the second.
Yeah. Okay. Woo. Same page.
Okay, what requirements must be met to ensure that p hat is normally distributed? It's the first one. Right? I hope.
Yeah.
Yep, the first one, yeah. Yeah.
So looking for test statistic.
Yeah, so that's in the Excel, and it is 1.
I have a 1.768.
Yep, that's right. Okay, and then the p-value is 0.961. Okay, and then the next one, we failed to reject it. So it's no, I failed to reject the null.
What was the p-value again?
It's 0.961.
Yeah.
So it's greater than the level of significance.
Yeah. I have a p-value of 0.039.
Oh, really?
According to...
Oh, wait, yeah, mine's 0.039 too.
Okay.
I don't know where I got the other number from. Okay, 0.039. So
that's less than 0.05.
Yeah.
So we reject the null.
So we say, yes, I rejected the null then.
Okay.
Right?
Yeah.
Yes.
Okay.
Okay.
All right, so this next part, I have no idea how to do it.
Okay.
Two SPSS away.
Through it. And
So you'll have to teach me again.
Oh gosh. Okay, so what am I looking for? Oh, we're going on to the review ones. Yes.
all right.
So this one.
So I'm going to read the question out loud because I have to process it.
Yeah.
Yeah, you're good.
Yeah, for sure.
This computer software is commonly used to translate text from one language to another. As part of his PhD thesis, Philip Cohen developed a phrase-based translation program called Pharo. The quality of the translation can vary. A good translation system should match a professional human translation. It is important to be able to quantify how good the translations are. The IBM T.J. Watson Research Center developed methods to measure the quality of the translation from one language to another. One of these is the bilingual evaluation understudy, or the BLEU. A BLEU score is a number ranging from 0 to 1 that indicates how well a computer translation matches a professional human translation of the same text. Higher scores indicate a better match. BLEU helps companies who develop translation software to monitor the effect of daily changes to their systems in order to weed out bad ideas from good ideas. Okay. So to compare Pharo's ability to translate with similar computer translation software, Cohen took a random sample of 100 blocks of Spanish text, 300 sentences, and used Pharo to translate each of these to English. The BLEU score was calculated for each of the 100 blocks. Scores are recorded in the data, and he wants to use the data to see his mean BLEU score differs from the mean BLEU score of another leading translation software. Okay.
So I think this one, if I did it correctly, is just doing an analyze,
Okay.
descriptive statistics explore, and you take the measurement, put it into the dependent list,
Okay.
then click statistics and make sure it's a 95% confidence interval,
Okay.
and then click OK, and then click OK. And that should give you an output with all the descriptives.
Mommy,
So that's how you do it? That's it?
That's how I did it?
Well, I was wondering because I was like, this is not, because this is an older one.
Yeah, this is reviewing for past tests.
Yeah, and that's why I was so
Unit.
confused because I was like, why are we using old stuff on the new exam?
Just so we remember it.
Okay.
So the lower bound should be 0.282.
And then the upper. 0.293.
Yes.
Okay, well that is way easier than I thought. Of course.
It always is.
Yeah, seriously.
Really good at overthinking everything. So.
Mm-hmm.
Yeah.
Okay.
Now I don't know this one.
Okay, yeah, so now we have to
Calculate degrees
do...
of freedom.
Cost.
Yeah,
To help you.
that requires like comparing the means and stuff, right?
She's getting drunk.
Calculated in SPSS.
I believe so. Yes.
I think so, yeah. So,
Okay, so
well, I can't
back
right
to
now.
the beginning and how we used to do that. I don't remember, but
Freedom, the test statistic, and the p-value.
did we do it by hand? Was that how we did it?
I'm going back and looking.
This is for the same.
Oh, it's n
Thing.
minus 1 for degrees of freedom.
One
That's a
minus
t-distribution.
0.
Oh, okay, so n minus 1. So it's 99 then.
It should be way easier. Let's see.
Sure.
Compare means.
So we've moved on from the. I don't think 99 is right.
Okay.
So mu equals 0.295. And
Which one are we still doing these blue score?
I don't think so.
Yeah, I think it said.
Wait, it's a
that-
different one?
Yeah, I think so.
No, it said to use it for the next 6 questions, so this should still be. And so if all you have to do is go into analyze, down to compare means, and then is it one sample t-test?
It's 400.
Well, I tried that. I did try that before, and it gave me a different confidence interval. And so that's why I was like, oh, that must be wrong, because it gave me a different confidence interval.
This gives me the same confidence interval. 38, so 0.282 for the lower, 0.293 for the upper. Gives me
Why is it giving me
as
different?
I
so
think we're doing a different test.
analyze, compare means one sample t-test is what I went to. And that
That's what I did too.
and I get 0.282, 0.292 for upper. I get degrees of freedom is 99. The test statistic is 109.
Okay, so did you put the test value in?
What'd you get for the test statistic?
109.091. But I think, see up here, it's the same thing. At the end of that question, it says, he wants to use this data to see his mean blue score differs from the mean blue score of another leading translation software, which has a population mean score of 0.295. So that's where we get the 0.295.
Okay, so you put 0.295 for the test value, and then you just click OK. See, I don't know why mine's totally different. Mine says lower negative 0.01262, upper negative 0.00216. I don't know why.
All I did from here, like instead of doing it instead of going through the descriptive statistics, go to
That's
Okay.
what I did. So I did compare means, one sample t-test,
And put the
the
score.
into the test variable. Then I did test value 0.295. Then I clicked OK. And then I got completely different confidence intervals.
See, I didn't put the test value in. Do we need to put that in? I didn't.
Well, the test value is the mean that was given to us. So his mean, so 0.295. That's the test value, because that's how you compare it. Because if we're comparing it, if we don't put the test value in anywhere, then there's no way to compare the value.
That's true.
If that makes sense.
Yeah.
But I don't know if that's right though, because the confidence intervals are negative, and they can't be negative, can they? Can they be negative? I don't even remember, honestly. I feel like they
confidence
can't.
intervals negative.
They can?
When you're comparing,
Yeah, they can.
when you're comparing them, they can, because it's saying that his are that much lower than the one of the others, and that much.
Oh, okay. Okay.
It's like because it's making a comparison. So
So if we do that, then it's negative 2 point something.
but
803 for the test statistic.
I don't know if that's right, but that's how I remember doing
So-
it though.
the lower bound and upper bound, I think, should still be the same as what we had it, because we're not comparing it at that point. We're just trying to find his true mean.
You're right.
and-
You're right. Yeah. So the first two would not change.
Yeah.
yeah,
The
those
first
ones we're
difference.
finding his, and then in these next questions we're comparing.
Okay.
That's the difference.
Okay, that's right. I was so confused. I'm like, they're totally different. But that's because this one says interval of the difference. So it's a different confidence interval.
Degree of freedom is still 99.
Yeah.
The test statistic is negative 2.803. Is that what you get?
Yeah.
Okay. And then the p-value would be 0.006
Yes.
Yep.
Which is lower than 0.05.
by a lot.
Okay, so we have sufficient evidence to say that it's
The true mean.
different.
Yeah, that's
Okay.
that's our alternative, is that it is different.
Okay.
So we have insufficient evidence to say the true mean is equal to 0.295.
Yep.
I think it's the first one. Because we're rejecting it, so we have sufficient evidence.
Yeah.
We have sufficient evidence that it's different.
Yeah, exactly. That's what I'm saying. Okay.
Does that make sense?
Yeah.
All right.
Excuse me.
All right, so are we done with, we're done with that set of data. I can close that
Yeah,
one
we're
and
done.
open the other. AM, PM heights.
Yeah, so this one always gives me issues. Like, I think I know how to do it, but then I try to
should
do
be a
it
paired
and then
samples.
it doesn't work.
Yeah, this is the paired one, right?
Yeah.
Because we're
Oh,
comparing
you have to do that
heights
first.
of the same.
That's right. Okay, so when you do that, you put the height in the morning in variable 1.
Yes. And then
And
when you
height.
have variable 2, it's height in the evening.
So that's variable 2.
Yes.
Okay. And then options, 95%. Okay. Oh, okay. See, I was trying to jump straight to the difference thing where you do compute variable. Oh, wait, I'm confused now. Do you compute the variable and then do that?
No.
Okay, so you do that.
So what you
and
do
then-
is analyze, compare means, paired samples, and then you have variable 1 is height, first one, and then variable 2 is the height, the second one, and then you do the options, 95%. You just do the thing, and then you click OK, and it comes up.
Okay. Didn't we also do something where we found like the difference between them?
Yeah, and then we use the one sample instead of the paired.
Yeah, but that's a different thing. That's not for this.
I believe so, yes.
You should get the same thing either way.
Oh, okay. Okay, cool.
Like if you go through transform, compute variable, and then which one comes first?
AM comes first.
AM subtract the PM, is that what they want?
Mm-hmm.
Okay, so AM minus the PM. And then all you have to do from there, analyze the one sample t-test again, and then you just put your new value in there, your difference that you came up with. So let's see if we do it that way. Let's see if we get the same thing as the other one. No, don't do that.
Oh yeah, you do. That's awesome.
Yeah.
I never. Okay. Well,
You
it's
should
way
get the
easier
same.
to just do the paired samples one then.
Yeah, it's just we were taught the other way, but it works both ways.
Okay.
Okay, so input the lower bound, it says.
Okay.
I got 8.728.
Yep.
8.728. Perfect.
4, 5. So 41 is 10.455.
Yes.
Yeah.
And then the test statistic is 22.446.
Excuse me. Yes.
And then degree of freedom is 40.
40.
Yeah.
40.
And the p-value
0.000.
000?
Yes.
Oh, so it's just 0. Okay.
And then based on your results, enough evidence to suggest that the children are taller in the morning than in the evening. Yes, because we rejected the null.
Yeah.
You rejected
Right?
the null. That's
Yeah.
what I got.
Yeah.
Okay. Let's see if we got these right.
I'm submitting it. We missed 3 of them. We missed.
Question 7.
Excuse me.
Question 8. And question 9. Oh.
We got
7, 8.
what? Which ones did we get wrong?
Wait, what?
Oh, the hypothesis significance level. That's the probability of committing a type 1 error.
That's what I thought it was.
Which is, I don't know, and 9. And 7 is, I don't. I'm honestly perfectly happy with the 93 right now.
Oh, dang
So-
it. I typed in one wrong. I just typed in the wrong number. Okay.
So what ones did we miss? Because I didn't yet. You guys said we missed something. So we got 7 wrong. Is that what you guys said?
7, 8, and
9.
9.
8 and 9. Wall Street Journal article.
Anyway, I gotta get ready to go to work, so I'm gonna skip out.
Okay.
All right.
So good luck on your
Thinking
test.
maybe 7
All right, you too.
is interval for 2 proportions, right? Proportion that.
Okay, so 7 in a Wall Street Journal article on satisfaction with career paths. Percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. Yeah, so that one's 2 proportions. Wasn't that the same question above? No.
Anyway, good luck.
All right, you too. Have a good
Thanks.
day,
All right.
Will do.
week. Bye. Okay, yeah, so I think it's the 2 proportions one then.
I think 7 is the 2 proportions, and then 8. Independent samples, maybe?
Let's see, what did they say?
Because we're looking for a mean, so it should be one of the ones that we're looking for a mean. So yeah,
Yeah,
Okay.
it could be independent samples because they don't.
independent. Yeah,
They
they
don't-
don't depend on each other. And then number 9 is the probability of type 1 error.
Okay. Dang it, now we have to go through the 45 questions and do them all again. That's so
So
late.
let me, and I will turn that one in. And, oh, we still missed one. What did I miss? Um,
Which one was it? Was it one of the ones we tried to change?
That's what I'm checking. I'm trying to see where it's at. Because I just scrolled right down to the bottom to see what we got instead of going through it all. These are all right. All the ones at the bottom are right. Okay, number 8. Number 8 is still wrong. So it's not independent samples, and it's not interval for 2 proportions. Are they paired? It doesn't seem like they would be paired.
Okay. For 2 proportions. Okay, so number 8. Okay, so double stuffed Oreo is supposed to have twice the filling of regular Oreo cookies. And some friends decided you want to know the true assertion by the company that makes them. Measure the amount of filling of each one.
Okay.
Well, we're actually, it looks like we're just doing a confidence interval for the double stuffed Oreos. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos. And actually,
Double
no.
stuff. You are some friend. Take a sample of 55 double stuffed Oreo and measure the amount of filling in each one. And you need to construct a confidence interval to estimate the true mean filling amount of double stuffed. Compare it to the filling amount in regular Oreo. So are we not looking for the regular? Would it just be in one sample T confidence?
Well, that's what it sounds like. And paired samples doesn't make sense because they don't depend on each
Yeah,
other.
they don't relate to each other. That's so maybe it's just the
T
and
confidence.
we're looking for the we're looking for the true mean and we're not looking for a proportion. Then I would think it was the confidence because we aren't giving the Z. So it has to be the. So we'll try Sample T confidence.
Yeah, I'll try that one, see if it works. Okay. Okay, 0%. Okay. Takes so long. Okay.
I know. We have to go through and redo all 45.
Okay.
Yeah.
Okay.
Thank you.
One nine. Okay, I'm almost there.
It's so long.
I know, it takes forever to get a 2.8. Okay. Let's see if it was right. Okay, so question 8. Yep, it was one sample T confidence interval.
Okay.
So I think it's because the question, it says you need to find the confidence interval for the double stuff Oreos. in
Yeah,
order to compare it.
they
So it's
treat-
not saying for both of them. It's saying for just the Della Stuff Oreos. But it's confusing because it says you're comparing it. So you automatically
It's like-
think too.
see if we can confuse you.
Yeah.
Okay.
Okay, awesome. Well, thank you so much for your help.
Yeah, I feel like we always do a lot better when we're together. So.
Yeah, it's true. Very true. All right, well, good luck on the exam, and I guess I will see you next week.
As the group do this Saturday as well. I'm just looking at it. I thought we had something.
Okay. Yeah, so collect the data is due. So all we have to do, I honestly don't know if it's been approved yet. So we'll have to ask Kara because you're not supposed to start collecting the data until he approves the study. But I'm sure he's approved it, and if not, Kara would have told us, you know?
Yeah.
So we all have to get like 6 bags of M&Ms, like the normal size, and then you just count up the different colors. That's all we really have to do. So pretty easy.
Turn in do we need to put it in together?
So we each turn in our own.
Okay.
So this portion of it we do individually. And then the rest of it, there's always going to be one person who fills it out. But for this one, we each have to do our own one.
Okay. All right. I just want to make sure I was up to date on that.
Yeah. Yeah, that makes sense. All right. Well, see you next week and have a wonderful week.
Yeah, you too.
Okay. Bye.